Welcome back. We're switching a little bit the schedule, and it is very good that we all have a chance to interact and to discuss. So it is my great pleasure to have Professor Robert Feldt from Chalmers here to share his experience with us. And it's not a joke, he was actually the first software engineering graduate, so he has a lot of knowledge about software engineering research and collaboration with industry within Sweden and also abroad. And thank you, Robert, for being here.
Thank you so much for inviting me. So I didn't know when I told Benoit he could say this that there's going to be cameras, so now I have to give you the background. Technically, there were many more PhDs who worked within software engineering in Lund and elsewhere, but the name of the departments in the 90s were not software engineering. I guess you could argue.
Yeah.
So yes, I'm going to talk about my experience from mostly working in software engineering, but the work that I do and my group do is also, you could argue that much of it is in software tools and software testing, for example, so it's also quite relevant, I think, for CASTOR. I must say, this is my Twitter handle down on the bottom, and I'm not, as a Swede, I must say I don't really like titles. So DR is Dan Robert Feldt. It's not Feldt. I was very young at the time. I didn't think the Feldt was already taken, and I just added my initials. And I've had so much fun. So how it started, I was a demo programmer on the Amiga. Well, it started way before that. So I was on the Texas TI 94 in the late 70s. And then on the Commodore 64 and 128, but it was really with the Amiga that I got into software development. Well, I didn't call it that at the time, but that's what I call it now. And here's how I looked, so that's a good start, right? Yeah, not much to do about that. Anyway, so for me, I mentioned this as, so my background was really that a computer is not only like an engineering tool in the bad sense of an engineering, that you can strictly tell it what to do, you can use executable specifications and everything is strict and upfront. For me, it's also like a creative tool, already from the start, right? So creating software, both creating the software has a very creative element, but you can also use it to create demos, explore the boundaries of computation and whatnot. So I think this is also something we need to keep in mind, because that might be quite important for future products. At least I think so. I don't want to dwell on what I do in software engineering, so I'll just flash through some things here. So a lot of my work has been on testing, but also a little bit on the bottom on automated programming. Requirements, you kind of need that when you think about testing, so they are naturally connected. What you miss kind of in the middle is design, UML and models, and I don't do that stuff. So just so you know, but then I also studied psychology while I was at Chalmers, and so throughout all of this, when we talk about technology, we try to consider how it will affect the actual engineers and the team and so on. So the humans in these kind of technology changes and using these technologies, we also try to focus on. And to do this, we have like supporting knowledge in empirical methods, statistics, AI, machine learning. We were quite early on using something which is now called search-based software engineering. It wasn't called that in the 90s, so we don't get any citations, but I'm not bitter. And then we have psychology to tie in the human aspects. I must say, nowadays, all the money is flowing into AI, so most of my projects now seem to be in applying AI, machine learning, and software technology to improve health, engineering, and medicine. But I'm also editor-in-chief, together with Tom Sim at Microsoft Research, for Empirical Software Engineering Journal. So, yeah, I don't know, in some sense, I do less and less research and more other stuff, which is sad, but true. Anyway, I also collaborated with companies, so I must show this very impressive list, of course, right? I've worked with aerospace, RUAG, bought the Swedish space, Saab and Ericsson Space, so optimizing testing processes, QA, also standards actually. I mean, many years ago, 10 years ago, we went with the ROEC space or Saab space at the time to meet ESA and to tell them that, you know, only requiring 100% code coverage is not going to be enough to ensure the quality you want. And they said, oh, really great point. We'll get back to you when we update the standards. Maybe in 2020s. I'm still waiting. They haven't called, maybe. Then we worked with Ericsson Karlskrona on software customizations, but more and more also, this was 2008 or so, on optimizing testing, so test selection and these type of things. ABB and so on, aligning requirements and test activities, this is quite important. Robustness and so on, yeah. Oh, look, it's so impressive. Wow, cool. IKEA, someone was here from IKEA, so we have one guy working on data mining, some of their software engineering data there. So this is just as a background, so at least you believe a little bit that I have something to say here, but I wouldn't say I know a lot. And I've seen many people in here who probably knows more about industry academia collaboration.
Question, what is VNV? Data mining VNV?
Verification and validation, so it's like the fancy academic word for testing and other stuff. Don't you agree? So, Swedish software engineering is growing. This is so impressive. Look at this. 2007, there were maybe 50 publications in the Web of Science in the area of computer science, software engineering. So this is, you know, it's not only one definition, of course, and not everything ends up in Web of Science, but you can use this as a proxy. So you can see now that this is only up to 2015, and you see like 2.5 times growth. It's actually linear, you could argue, so it's not that impressive. It could be much better, but anyway, probably if we looked at the last 2 years, it would be even more impressive. But you know, it takes time because before everything comes into the database, so you can't really use latest years. But this is a good sign, and if I could take some other proxy. I mean, we could count the number of faculty members and so on. It's been growing a lot since the 90s and so on. So it's a very clear trend, and I would say now with CASTOR Software Center, I mean, in Chalmers, in my division now in software engineering, we are 60 people. When I started my PhD, we were like 0.1, because no one was in there. My supervisor was professor in fault tolerance, and he said the first day, "Oh, I know nothing about software. It's the future, but please go ahead." So what's your question? Yeah, and that was actually Jan Turin, who worked at Saab, and he was my supervisor, and his supervisor was Erik Stemme, who built BESC, the computer. So Stemme was my academic grandfather. Yeah. Stemme was also well known because the only time you could see him in the department was at 6 o'clock in the morning. He always worked between 4 o'clock in the morning and 6, and then he stormed out of his room and you never saw him through the day. He was also very rich because he was on the patent for Bleckstråleskrivare, what's it called? Inkjet printers. He sold that to Canon in the 70s. Right. But you can take another proxy for why also not only software engineering research has grown, but also the collaboration in software engineering between industry and academia. And the proxy I found the most interesting here is that the number of papers that talk about how do you do centers like CASTOR, how do you actually work with industry. From 2006, going 10 years forward, all of those papers were authored by Swedish researchers. So I think this is actually an indication that we were very early in this, right? So it started with the famous tech transfer model by Gorshek and Volin in 2006. And then a little bit later about what is really relevant for industry and how can we evaluate that, right? And then it goes on. And Sandberg was from the Gothenburg Chalmers gang, Runesson in Lund, Sigrid is here. Many people have worked on this, and it's not only it's only in the last 2-3 years that you see foreign authors of papers really that talks about this, right? So there's a rich literature on like meta level. How do you actually make it work? So you know, I'm sure that the CASTOR people knows about this, but if not, I mean, here's a reading list to get you started. So the Gorshek model, I'm not showing it because I think it's super great, but I think it was early and it put a few important things on the map. So you have like, the first thing in the model is that below the line you have things that happen in academia, and above the line you have activities, etc., that are mainly hosted or happens in industry. And I think this is an important model just because that industry is in there, right? Before 2005 and 6, it was more like, why would we work with industry? Or at least, you know, it took 20 years maybe to make this vivid enough and clear enough that you can put it in a model like this. So in some sense, the problem should come, in some sense, from industry. That should lead to some basic, you know, pre-studies, maybe studies on candidate solutions with students here in step 4. Then you can do, static validation is you go out to the company, you ask them, would this tool work for you? Here's how it works, here's what it can do. Would this actually help you? Okay, maybe it helps in this aspect, doesn't help in that, and so on. And then you can go back and you can refine and so on. And then dynamic validation is you take the tool and you actually measure what are the improvements in actual use in industry when you apply this new technology or tool. So I think these parts were very important. It's also very important that they point out that even after you've shown to industry that this should probably work pretty well for you, there's a big and hard step to actually make it, deploy it in an organization. I think there's way too little focus on step 7 there. And I'll get back to that. Here's another one, Sandberg. This is quite recent. So this actually not, this doesn't show the Chalmers software center. This is not how they work. But here they show one of the benefits is that it's not only that you get on top, like industry and academia talks to each other, you also get within company A, say Ericsson or Saab, because they hear about, they come to a workshop like this, they can hear about new technologies, maybe used in Ericsson in Stockholm, but now it can be used in Karlskrona or somewhere else, right? And of course you also get between companies, and this is the thing, when we've done national research schools, industry days and so on, number 3 is often what the company practitioners like the most. Oh, I loved hearing about how ABB has the same problems or even the different problems. And here's some ideas about what they did that I might be able to use as well. So I'm not so sure that it's always the direct outcome of the collaboration is not always the most important, right? So enabling all of these different kinds of interactions is probably also going to be important with CASTOR. Okay, now comes my great model. So here comes my own model. It's called the Industry Academia Collaborations Stages, but you could say Industry Academia Collaboration Maturity Model. It sounds pretty cool. IACMM, right? So if you start one level of industry academia collaboration, you can have is the gap, or also called the blame game. This is a level which doesn't work very well because none of you really want to be in the collaboration. So you rather kind of explain already from the outset why it's not going to work because we are so different. Or maybe you don't even get started at this level. The next level is coexistence, which means now we can be in the same room. We're turning the backs against each other, but at least we're there, right? So there's some kind of exchange or interchange at this step. Then the best level, or the next level, level 2, is we're actually interacting, right? And many of the literature I showed you before is about how do you make this even stronger? How do you make level 2 actually work? What are the type of things and activities you can do to make it work a little bit better and so on? I think that we want to aim for something more than that, which is actually that we value and see each other and try to co-create knowledge and learn as we go along, creating longer, mutually beneficial relationships. But, you know, it's not like a single project will only be on one level, but you have to think about different levels, and it's not good if you're only on lower levels, because then you will not create so much value. And of course, the chance of success increases here. Success means both for both parties, to have research impact, to have industrial impact. But of course, the time you need and the trust that you need to build probably also goes up quite a lot. So I think this is a very basic set of stages. I'm not claiming it's very original, I haven't checked. There's probably much better models out there, but at least I've seen all of these levels, and I'll go into some more details. So level 0, the gap, or the blame game. So the best picture is maybe to show mind the gap, because there really is a gap. I think many of you know this. We have different objectives, different incentive systems, different time horizons, and so on. And all of this can create kind of a mayhem, because we don't understand each other, and at some point it might be that, okay, it's just kind of a blame game, and there is no real collaboration going on. So typically, you know, I'm taking the extreme view, but what industrial practitioners might say in this level 0 collaboration is, well, the academics only want to build their ivory tower nice theories, and they don't really care about solving our real problem. I added our, but you know, real problems is of course our real problems. And you know, there are many kind of other signs of this view, and I think even though few people today have it, I think it's important to have in mind, because also within academia, you see other departments might have this view. You know, so you might even hear this as an applied researcher trying to do collaboration. Well, you're just a consultant or whatever, right? So, of course, and this is how the academics talk about the industrial practitioners. Well, they want to find quick solutions to problems that we have already solved many times over. They basically want me to be a consultant, right? So this is the extreme view on academic side that, okay, and you know, the worst thing is that they don't even describe this in a, this looks pretty cool to me, right? But in some sense you could characterize, well, in industry, they basically do things out from a given script, and there's not much more, you know, it's basically repetitive, and there's no real artistic creativity involved. So this would be another extreme kind of view that an academic. Probably today it's very rare, but you can still kind of see the shadow of this type of view. So I think it's important to have in mind. So what does academia say here? Well, industrial problems lack scientific novelty, so you know, obviously we cannot touch them. Industry would counter with academic solutions are impractical and hard to apply. You know, there's no documentation, and so on and so forth. Industry is short-sighted. Academic solutions don't scale. Well, this is true, actually. But you know, why would we have to scale them up? But that's obviously your problem. Right? Industry don't dare taking risks, and I think there's some real truth to this one. I think this is maybe the one I think where you have to really think about it a little bit in industry, because I think at least the tendency, from my perspective in Sweden, has been government forces now, you know, researchers together with industry, and then it tends to be quite short-sighted focus. It's rarely that these type of research projects lead to the most daring and new kind of steps. So I think this is a problem for the nation. That's why we should care. And of course, academics study problems we don't care about. There are even papers showing how wide the gap is. So they went out to industry practitioners. They asked them, what are your most important problems in software engineering and so on. Extremely detailed, very nice methodology and so on. Then they compare to the best conferences and they see, okay, how much is the overlap? It's very little. Right. Level 0, there we go from the big rift that was on level 0 to level 1, coexistence, which is, okay, there's still a gap, but we are kind of closer and we're kind of in the same room, right? But there's some real problems kind of existing here. So both sides have decided, someone on both sides have decided that we want to do research together. But this does not mean that all individuals that are in the project have the same view, right? If I'm in industry and my manager tells me you're going to be in this research project with CASTOR, I might feel like, oh, I'm not so sure this is the best for my career, or I wanted to finish this project where I have a customer in Japan or whatever it is, right? So just saying that you need management support, which is what you'll find in all the 12 papers I showed you earlier, said, oh, the most important is to have management buy-in. Well, that will not help the engineer that Benoit has to talk to at Saab if he's not interested in this collaboration, right? So there's much more kind of a human aspect to this. So it's not enough that someone decides that you should do a project. You need to have real interest, commitment, time, and collaboration skills on both sides. So one thing that happens is that you set up a project, and this takes like 6 to 12 months to get funding from the government. And then when you start, the company says, well, that project we stopped selling that project, so we're not super interested in testing for this type of model, and so on. Researchers can be in this because they must be in this to get funding. That's why they are in the project. So they would like to do their normal research when you're in the project. This can happen. Another one is a little bit more subtle, is you start a project, the person you're talking to is super excited and so on, but it turns out they started at the company 3 months ago, so they know enough. They don't know anyone, they don't know the structure, they don't know who could have the data you need or couldn't provide the interviews you need and so on. So, it's not likely to lead to so much. And yeah, this is what it leads to. So in a sense, in this type of project, and I'm not saying that whole projects are like this, I'm saying that this can be an aspect to collaboration in software engineering, software technology. Both parties might be sitting off the time rather than trying to really do something with it. Okay, let's go to level 2, interaction. So here we're really trying to bridge the gap. There is a gap. And I have I couldn't find a picture, but I've used it before. It's probably a fake picture, maybe you've seen it, but it's basically they're building a bridge, a real bridge, a large bridge, with several lanes from 2 sides, and when they get close they see that it's like 3 meters difference where they're supposed to be. But it's probably a fake picture. So I took this one. So here we are really trying, we are committed in some sense, but of course it's not easy, that's easy, right? So both sides are really trying in this one. And they want both something useful out of the collaboration, but normal operations of the different, incentive systems, organizations, how these different organizations work can get in the way. And also this one is very hard. Cultural and subtle differences can also get in the way. One thing is also that academics often are focused on generalized knowledge, while industry people want very contextualized, adapted solutions. And this can be quite hard to bridge, even in a sense technically. I mean, this is not really what, from scientific perspective, that's not really what we want to do as researchers. So this can be problematic. IP, I'm very glad you mentioned it's solved here, because it can get in the way. For example, I've had projects where it is solved, but it says we need, the company must see any papers 3 months before the deadline, and most academics don't even know what should be in the paper 3 months before the deadline. So that can be problematic. And if you are from industry and you just think at this point, well, why don't you just move your planning 3 months ahead? I mean, that also illustrates the cultural difference. Now we come to the really hard one, and I think probably a key one. And this is what bit me. This is probably why I stopped doing a lot of industry collaboration. Deployment and politics can get in the way. So even when me and my group have adapted, shown on company data in the company environment, here's how many millions you save per week or month. The answer was, yes, we know, it's great, but that boss over there doesn't like it, right? This can be, imagine the long-term effect on you. You took all the pains to build the trust, to do the research project, to invest your commitment and time, and then for some peculiar, just this week, political reason, someone in the company decided to not be so nice to your contact person. Okay, this can be devastating. To me, it has been. Well, don't start crying. Sandberg. So this is the level 2. Here you find all the nice models. So here's one from Sandberg. So this is Anna Sandberg was at Ericsson in Gothenburg. So she took something called a collaborative practice research, which was from her supervisor, Lars Mathiasen in Denmark. And here the idea is extremely nice, right? So it's kind of, instead of making the differences between academia and research a problem, it kind of takes them and makes them the good starting point. So in industry you have acting practitioners. They're running around, they do stuff, they really impact the world, as we heard here from Ericsson before. But they have challenges, right? And then you have the reflecting researcher who has more time to think, maybe can try things out and so on. And if you really can get these two together, and the CPR actually gives you specific advice and things to do to try to make this happen, then of course something really good can come out of it. So there's a lot of literature on this. And I would say that kind of Anna Sandberg was early on Ericsson, Chalmers, GU trying to create a collaboration. So from 02 up to 10, they published this. And I would say that these ideas are the main basis for the Chalmers Software Center. I mean, this is the type of thing they are trying to do. And the model is, of course, very nice, right? This is what you need to do to publish it. So there's like 2 levels here. I mean, so there's like research activities. First you need, oh, there we have it, management, buy-in and engagement, right? This is the basis for everything as usual. It's, of course, that's how they work in industry, right? If you have this, everything flows without problem. Then you need access to the network, you need the right collaborators, you need communication ability, and you need to do this long term. And then this enables results, which has other steps there. So I'm not blaming this in any way. It's a great model. But I think it doesn't focus on the humans involved. It focuses on steps you need to do, and if you do them, you're successful. I think there's another aspect to it. Yeah, so one thing that can happen here, which is a little bit subtle, is that academics, they have a few tools that they really, really like, right? Me and Benoit, we like diversity, for example. I mean, we like many things, but we have some ideas that we really think, well, these are really good ideas, right? So the risk here, even if you're trying to make things work, is that you, in some sense, you are applying your set of hammers, right? Maybe there are several hammers, but this is the risk. I mean, my experience in industry is that you need to be a little bit like a consultant. To help people solve a real problem, you need a little bit of everything. You need, maybe psychology, maybe hardcore software technology and something else. But this can be a problem on this. Yeah, I already talked about this one. I'm sorry for putting Trump there. I mean, it's like impossible to do an image search for politics and don't find the image. But I mean, the problem is really serious, I think. And I think many people in here have seen it. I mean, of course, not with Trump. I mean, in industry, that's another type of problem. Industrial politics and power games, I mean, this can be really devastating. I think long-term devastating for people trying to do this. Because it can get away from rational discussion and decisions and problems. IP rights, we already discussed this, so this can be problematic even when everyone is trying, right? I think this issue is not something where academics are really great. So I think for all the companies here, you probably need to take a little bit more drive of this issue because you have much more expertise on this. And I think in general, you need to open up more. If you look at Google, Facebook, even the Chinese companies that are some of your competitors, they are more open now. And I think Ericsson has been very open, but I think in general in Swedish industry, I mean, this is not going to be the problem, that someone reads your paper and so on. You can always fix things so you don't reveal really the key things here. But it's an important one. So I found an old thing. So we had many years ago here a Swedish, it was called Swell, Swedish VMV. So here's that word. So it's not a double V, it's like 2 single V's, right? Really funny. Swedish VMV Excellence PhD School for Sweden, basically something. So we wanted more PhD students in testing, and we used this scale for industry involvement, and it was quite useful. Vinnova liked it at the time. So basically, level 0 level of involvement at industry is that you don't just have some initial context, right? So you don't really know what kind of involvement you will have. Then you can have visits at different levels, I mean once or recurrently, and then you can have exchange, actually getting data, and a lot of early software engineering collaboration in Sweden here was about just getting data from companies. But of course there are many levels to collaboration, I mean, and the top one is the one I like the most, which now I mostly do with Saab actually, industrial PhDs that are Saab employees and are only like 50% doing a PhD, I think is a great model. But this was quite nice, and then we, for Vinnova, we kind of took all our PhD students and we showed like this, where they were, right? So this was really useful to kind of make it visual and simple. What kind of, with whom are they working and at what level? And here were more like prospect stuff they were doing. So, you know, simple models can help to really deepen things here. Okay, I need to speed up. Okay, and there it is. Yeah, so level 3 co-creation. Was quite fun to search for an image for co-creation because the only one I really found was this is advertisement for Philips light bulbs. So I didn't expect that. But so you really need light, right, when you're doing it. So what do you do here? So, I mean, so this is like top level collaboration stuff. So what you have here is a long-term relationship, and it must be based on mutualism and trust. And okay, now yeah, the cameras are here, so maybe I don't know what to say, but I think there are a few centers in the world and in the Nordic countries that are super good at this, right? And I think a problem is mostly for the companies. So government has forced academia to jump when companies say jump. And I think to some extent, some centers are doing that too much. And this is a risk. If you want mutualism and trust, it also means that the companies need to respect what the academics need to do and what their objectives are and so on. And those are often to take a little bit more risk, do long-term research, and there's a way to find a combination. But you know, if it's going to be about companies and government telling academics how they should do things, I'm not so sure that's going to be co-creation. I think that will be something I do on the side, part of my time to fund what I really want to do. I think that would be a shame for Sweden. So, if you want to make this level work, you need to focus as much on relation and human aspects as on the technical, practical, and process aspects of your center and collaboration. And it's critical to achieve understanding of each other's realities, right? So I don't want to hear academics, you know, misunderstand Ericsson and Saab's reality, right? We can do better than that, but I also don't want to hear Ericsson people say that we're a pie in the sky, up in the air, doing our theories, because, I mean, it's not going to work like that, right? You cannot force someone into co-creating knowledge. But is this prioritized by companies? Here's Swedesoft March 2018 report. And here's what they see as barriers to their future business expansion. These are, we asked many software companies in Sweden, and they say they don't see any barriers. It's number one, that's interesting. Good for you. Number two is we lack the technical expertise, right, to give us a competitive edge, and so on. And second to last is we lack collaboration with researchers to create, yeah, competitive edge. So, you know.
But couldn't you interpret the lack of edge competence?
Yeah, I mean, here's one, right? So there are other ways, of course, to play into this. But I think, yeah, we need to understand these realities and maybe also think about it. I mean, if some of these things here feeds the others, so that could also be a reason for industry to think differently about it. Anyway, I'll conclude because I think I've taken a little bit too much. It's okay?
Yeah.
It is great and very important to get good industry-academia collaboration going. It's very good for Sweden. It's very good for the companies here, and it's good for the academics. So the best collaboration projects I've been in has been ones where we had an industrial impact, but we saw what was lacking in the research literature based on these problems we saw in industry. Then we did basic research to develop such new statistics, mathematics methods, and then later we could increase the industrial impact by implementing. So I don't see really, and you know, I'm very frustrated being at Chalmers, because if you're a software engineer at Chalmers, then, you know, well, you're doing the consultancy stuff, right? Like 80% of the computer science and engineering department at Chalmers, they are not doing software engineering, right? So they value more theoretical and other aspects. But it can be quite frustrating to hear this, right? So now I lost my thread on that one. But anyway, I'm frustrated. That's what it is. There's a large literature on how to make it work in software engineering. Much of it actually based on Swedish experiences. The literature focuses on processes and practices, though, not so much on human values, motivation, expectations. I think this is a lacking a little bit. It's probably in there. Sorry, Sigrid, if it's in your paper. But you know, I think it's not in a paper that makes it front and center. Let me put it like that. And to develop long-term and mutually beneficial collaborations, you must consider these soft factors, because you know, when these things work the best, like with actually Saab, then we've had now projects. I think we're on the third consecutive Vinnova project in NFFP, so it's National Aerospace Research Program. So we have 3 in a row with them, and it's because they know us. They know that it's going to come out something good at some point. Maybe not exactly what we plan for, but something good will come out of it. So they can also ask us, should we apply? It's not always that we need to go and say, you know, we really need to apply here. To come with, you know, our hat in the hand, as we say in Sweden. Yeah, that's it, I think. Thank you.
Thank you. Yep.
So if we are well best in producing papers about industry academia collaboration, are we then also best at it?
Well, I think there's clearly an argument to be made for that. I mean, it's very hard to measure the quality or the industrial impact of this. But if you look at number of co-authored papers and so on, I think it's pretty clear that. And also, one example is ICSE, so the main conference in software engineering was in Gothenburg at Chalmers in end of May this year. And I think it was the record largest conference, 1,800 participants, out of like 500-600 were from industry. And most of the US and UK and Europeans thought that was outrageously high number. They said we would maybe get 50, you know, or 100. So I don't know if it's true, but that's what I heard. So, you know, in some sense, I think the fact that we can discuss soft aspects is probably because we've done this and we've run into the problems during many years. So I would make the case that we're definitely in the top 3. Yeah.
Is this gap that's been primarily research in Sweden, is this perhaps a Swedish problem, or is this an international problem, in your opinion?
Yeah, I think it's a global problem, right? I mean, this is how people view like Einstein or something. I mean, this is how people view science. It's that it should be about, you know, strange things up in the air. So I think the cultural or global kind of headspace for viewing researchers or scientists as practically useful is pretty small. So, you know, I think it goes through most countries. Otherwise, they would be better at doing the collaboration.
This somewhat a little bit relates to your question. So when I came to Sweden 15 years ago. So my background is German, and I used to work at a research center. And when I came to Sweden, I was really surprised that universities would directly collaborate with companies, because, you know, in my experience, it gets so much easier if you have a research center, you know, as a partner, right? Because then the gap you have to bridge becomes much more narrow, right? So Fraunhofer is not has not been created to be world-class research, but world-class transfer. So and that always struck me, and you know, still strikes me as something that makes it a little bit more difficult than it needs to be in Sweden.
Yeah, I mean, maybe there are some people here from RISE 6.
I used to be at RISE.
Well, until I think many academics would some academics would view RISE as could be that thing. I don't think RISE or 6 is that thing today. I mean, the way I see it, it's mostly like we're competing from about the same grants. So you know, no one is really filling that space. I think today.
Another question? Yeah.
I guess you presented your maturity model.
Yeah.
And then you formulated a number of problems and questions.
Yeah.
I guess you could turn them around and say, if you turn the problem around, then you get the solution. Is that how you think? Or
Basically,
because
I think awareness of the problem is like more than half of the solution problem. I think the main problem is that how many people discuss that we want, you know, the first thing is engineers are also people, right? Not everyone in society would agree. You know, I think many academics today agrees. But the second one is researchers are also people. I think very few people have that view. You know, so, case in point. So I think, just changing that is probably a good thing.
Thank you.
Oh, there's one more.
Oh yeah, there's one more.
So let's say that we have somehow achieved this nice collaboration, right? Is there some metric to evaluate it? How well did we do? Is there anything in the literature regarding that, or the answer is just, well, doesn't it look nice?
Well, you know, I wouldn't go for the quantitative metrics. I would go then to psychology and see, can we measure the happiness in this collaboration, right? If it's long term, that's a better indication that how many ICSI publications did we get out. You can use quantitative measures, but I'm not so sure that's going to measure the long-term sustainability.
Maybe I can add.
Yeah.
Usually we measure like publications and patents and such, but also we use impact descriptions. Good cases where we have co-created things that we describe in text. So it's not a number, it's more that we describe by using that and that good examples on how to do it. And usually that is also part of the evaluation of the collaboration.
This comes from UK's REF, how they evaluate academics. Is that capturing everything? I mean, I've written such cases without being happy with the collaboration.
Thank you.
Thank you.